friends, this is Fahad from Game Code Bytes. It's going to be the first video in the channel. And to give you a brief introduction on the channel, what is this all about? I'm going to build video game mechanics, systems, logic, and all things related to video games, but in small chunks. And when I say building, I mean writing code. The main language I'm going to use to write the code is JavaScript. Pure JavaScript. No libraries, no frameworks, but maybe in the future we'll do some libraries or frameworks. We'll see at that time. In this first video, I'm going to guide you through the process of building one of the most famous mechanics in video games, which is bouncing. You'll see it a lot now and before in many video games, like Super Mario, Sonic, Crash Bandicoot, where you have a character that jumps on a spring and it keeps bouncing off that spring. So let's get started. Okay, so the first thing we need to do is to create a folder for our game. I already created one. It's called Bouncing. Now, in that folder, we need to create 3 files: index.html, index.js, and style.css. I prefer to use terminal to create those files, but you can do it however you want. Okay, now I have the required files for our project. Now I'm going to use Atom as a code editor. So I'm going to open Atom. Okay. Now I have the code editor opened. I don't need this file. And I have all of the 3 files required for this game. I'll go to the index.html and create a basic HTML file. We need to have a reference to the style.css file. So I'm going to say ling. No, it's not li. It's going to be ling. Yes. It's nice that in Atom you can write like the beginning of a keyword, and it will recognize that, and it's going to autocomplete it for you. Style.css. I'm pretty sure this option does exist in many editors nowadays. I'm going to call it bouncing. We also need to have a reference to the JavaScript file. So script src is going to be index.js. Nice. Now the next thing we need to do is to create a canvas. So what is canvas? Canvas is an HTML element that allows you to draw things on it. It was introduced in HTML5, so I'm just going to create a canvas element. In future videos, you'll see that we're going to create the canvas using JavaScript, not in the HTML. But it doesn't matter. We can do it this way. As you can see, I created the canvas element. It's pretty easy, straightforward. I also gave it an ID of canvas so we can use it later on. Now I'll go to the style CSS and add some styles there. But before that, I'm going to open my browser and so we can see the results directly. Okay, I'm going to shrink this a little bit. I'm going to add some styles for the HTML body. I'm going to say background is almost black. See, now it's black here. And also I'm going to add some styles for the canvas. We'll give it a background a little bit lighter than the HTML and body. So display, block, margin, 0 auto. Maybe a little border. So let's say solid, 2px, maybe this way. Okay. Now I can set the width and the height of the canvas in the style.css, but I like to do that in JavaScript. Now we'll go to the JavaScript and we'll add the logic, the required logic to build the bouncing system here. All of the things we have done, they're pretty basic. And in future videos, we're probably going to skip those steps because, as I mentioned, they're basics. We're just creating index.html and a style CSS and have a reference to those files within the index.html. Okay, now the first thing we need is to get a reference to the canvas element. And to do that, we'll declare a constant, call it canvas, and then we say document.get element by ID. And because, if you remember, in the index.html, we gave it an ID of canvas. So that's how we get it here. The next thing, we need something to draw with it. We know that canvas is an HTML element we can draw on it. But if you think about it, canvas is just like the paper. But the pen, it's something called context. It's a JavaScript object. You get it from the canvas that allows you to draw on the canvas. And to do that, we will declare something called context. And then we say canvas.get context. And then we say 2D because we're going to draw 2D on the canvas. There are some other contexts like WebGL and so on. Okay. Now let's set the width and the height of the canvas. So let's say 320 canvas.height equal 480. Okay. Now, if you look at the canvas here, it's kind of like stick at the top. And we can do it by pushing it to the center of the screen. And we can do that this way. Canvas.style.margin top equals window.inner height divided by 2 minus canvas.height divided by 2 plus px. Okay. And just to make sure you can see what I wrote, just gonna zoom out a little bit. So what we have done here is that we said, okay, I'm going to push the canvas to the window inner height divided by 2. In window inner height divided by 2, it's something like here. But because of the pivot point of the canvas is here, so that means it's going to push the canvas here. So that's why we said canvas.height divided by 2. So if we remove this, you'll see it's here. So I just wanted to explain this so it doesn't look like we just wrote some magic here. Okay, now we need to represent the player of the game, or like the character of the game, or like the hero of the game, by some drawing. Let's use a simple box for that. And to do that, I'll create a box object. So I'm going to say box, and then it's going to have x. And let's say the x is going to be canvas.width divided by 2. You know, I'm going to do some things a little bit simpler. Const width equals const height equals. So we are setting the width and height of the canvas, but at the same time we're storing these values into constants. And I can refactor this to the height instead of canvas.height. I'm going to say width divided by 2 minus, let's say, the box size, or maybe box width equals, let's say, maybe 30. Const box height equal 60, for example. I'm going to take this and put it here. Okay, minus box width divided by 2, y height divided by 2 minus box height divided by 2. We're simply just centering this box in the middle of the screen. And by the way, we're calling it box. Some people think this is kind of like a square, but it's more of like a rectangle shape. But it's okay, we can just call it box. Okay, and width is going to be box width. Height is going to be box height. Going to give it a color. Let's use orange. The next thing I need is velocity, because we're going to update the box speed all the time to be attracted by gravity. But also I'm going to give it x as well. So x and y both are 0. Nice. Now let's try and draw the box, and just to see if we did things in the right way. So we can do it this way. Remember I told you that context, it's like the pen. It's the object that is responsible of drawing on the canvas. So first thing we need to do is context.fill style, just give it a color, and the color is going to be box.color because we gave it the color here. Next, context.fill rect. It's going to create a rectangle. So I'm going to say box.x, box.y. We set the position on x and y, and then box.width and box.height. And we should be able to see the box in the middle of the screen, or in the middle of the canvas, actually. Okay, now we were able to draw the box in the middle of the canvas. Now we need to move the box, to animate the box, to let the box get affected by the gravity force, because this is all about the bouncing. When you do a bouncing effect, a bouncing system, you need the gravity effect that keeps pulling you down to the spring. And then once you hit the spring back, you will jump back in the air, and then the gravity force will attract you back to the spring. In order to do that, we need a function that repeats itself over time. In some other languages, we use something like a timer to do that. In JavaScript, we used to do something called set interval, or even set timeout. But there's a better function nowadays. It's called the window.request animation frame. It's basically, without overcomplicating things, it's basically a method that tells the browser that you wish to perform an animation. And that function also is going to take a callback. So let's try the request animation frame. But before that, I'm going to call the function called frame, or maybe update. And then this update, I'm going to call the request animation frame function. As I mentioned, the request animation frame takes a callback function. What is the callback function? It's going to be the update itself. Maybe you can call it frame. I like to call it frame because it's kind of like saying this is a frame in time. This is one frame in time. So it's going to be like this. Now we need to call it at least once by saying frame. Now let's try and animate the box. Box.y plus equal 0.5. But if I run it now, it's not going to do anything. Why? Because it's right. We are updating the y position of the box, but we're not repainting. So I need to repaint after updating the location or the position of the box. Okay, nice. We're making progress here. But what is the problem? Why it's like moving? It's like snake game. Well, because it's your responsibility to clear the previous location in the canvas. And to do that, we'll do context.clear rect from 0 0, which is I want to clear everything from 0, 0 until the width and height of the canvas. This is not the optimal solution if you want to build a performable game. You shouldn't clear the canvas on every frame. But for the sake of simplicity, we'll just do it this way now. Okay. Now, we should be able to see the box falling down. Nice. Okay. Okay, now we have the box falling down to the bottom of the canvas. Well, we need to do a little bit of refactoring here. We need to build some kind of like a real physics here. We need to update the velocity of the box instead of the position of the box. We will update the position of the box on the y-axis, but it's going to be affected by the velocity on the y-axis of the box. And I'll explain how. So I'll say box.vil.y plus equal, for example, 1. So what is velocity? Velocity is a mathematical component or a physical component that has magnitude and direction. So velocity, it's like saying speed with direction. When you say speed, that means it's only speed, it's only magnitude. It has only a value. But when you say a velocity, you're saying speed with direction. North, south, or with angle like 45 degrees or radian, or however you want to represent the direction. So we want to update the velocity of the box on the y-axis by 1, but maybe a better way to do this is to declare a constant called gravity. Const gravity equals 0.5, and then here, instead of saying 1, we'll say gravity. Okay? Then we will update the position on the y-axis of the box by the velocity. So I'll say box.vil.y. Okay? Now if we uncomment the frame piece of code, or the function call, we'll see the box moving quickly. Not quickly, but it will accelerate, because every frame we get in, we will update the velocity on the y-axis by gravity. So the first frame is going to be 0.5, second one is going to be 1, third one is going to be 1.5, and so on. So let's try it out. Nice. Okay, now we have the box keeps falling down towards the bottom of the canvas. This is good. But let's step back and think about it. If in real life, if you throw a box in the air, what's going to happen? The box going to fall down, and then once it hits the ground, it will be placed on the ground, right? So we need to do the same thing in our simulation here. So I'm going to write the code, and then I'll explain the logic behind it. So we'll do it this way. We say if box.y plus box.height greater than the height of the canvas, then the box y position equals the height of the canvas minus the box height. Okay? And then let's test it out, and then I'll explain it step by step. Okay, good. Okay, good. Now let's explain it. If the box y position plus the height of the box is greater than the canvas height, then put the box y position so that its y position is equal to the height of the canvas minus the box height. That's it. Okay, now we have the box falling down, hitting the ground, then we're placing the box on the ground. Now we need the bouncing mechanism. And to implement a bouncing mechanism, like a simplest way of bouncing, is going to be straightforward, super easy. We just say if the box hits the ground, then we need its velocity on the y-axis to be reverted, multiplied by -1. Now let's try this out. You see? It's working. And why it's working? Think about it. If the velocity on the y-axis of the box, let's say, was probably, for example, maybe 3, okay? Now it's 3, 3. It keeps increasing, by the way, 1, maybe 2, 3, and then it hits the ground. What we're saying is that revert the velocity so that it's going to be -3 instead of 3. Now the velocity is -3. It will go back to the top, but we keep increasing the velocity by the gravity, and it will go back again. -2, -1, 1, 2, 3, and back again. Okay, now let's try to change the gravity. Instead of 0.5, let's try 1. It's going to be a little bit more aggressive. Okay, let's try 2. Nice. Let's try 0.1. 0.1. It's kind of like floating in the space. So let's try 0.7. It's good. It's pretty decent value for gravity, specifically for our simulation here. Okay, now we have the box falling down and it will bounce off the ground. Now let's add some movement to the left and the right. Once we press right and left on the keyboard, we want the box to move right and left accordingly. So we need to listen to key events. So I'll say document.body.add event listener. It's gonna be key down, I think. And then we use arrow function here. And we need the event. I'm just gonna call it E. So I'll say if e.keycode equals, I think left is 37. So if it's 37, if it's left, then we need the velocity on the x-axis of the box to be -1 because you're going left. So box.vil.x equals -1. Just a simple way to do it. Okay, let's try it out now. It didn't work. And why it didn't work? Because we're not updating the x position of the box by the velocity on the x-axis. So what we need to do here is say box.x plus equal box.vil.x. We always need to update the position of the box on the x-axis and the y-axis with the relevant velocity on the x and y-axis. Let's try it out now. I'll press left. Yes, it's moving. Nice. And we'll fix this issue of the box that keeps moving to the left. But first, let's do this. Let's say if key code equals I think it's 39, then we need to set the velocity on the x-axis to be 1, positive 1. Let's try this out. Okay, nice. So we press left and right, and the box will move accordingly. Nice. Now we can do something. We can either say, if we're lifting our fingers from the keyboard, we want to remove the velocity. We want to set the velocity on the x-axis to be 0. Or we can do something pretty nice. It's kind of like a video game, complete video game we're building here. So we'll say, so what I'm going to do, I'm going to say if the box hits the right or the left of the canvas, we want its velocity to be reverted. And we do that this way. Let's put it here. We'll say if box.x plus box.width is greater than the width of the canvas, or box.x is less than 0, then box.will.x multiplied by -1. Just revert it back. Let's try it. Okay. Oh. Okay. Let's try it out. You see? This is good. Okay. Now, let's try increasing the speed on the x-axis every time we hit left or right. So I'll say, for example, 3. And let's try it out. Good. This is good. Also, we can refactor this so that we don't need the whole event of the key down. So we can just say key code. I like to put some spaces. So instead of saying e.keycode, it's going to be keycode like this. Let's try it. And it's working. It's also nice that we can also change a lot of variables or constants, let's say here, and this simulation is it's still gonna act just like how it is acting now. And by that I mean, for example, if I say the width, instead of saying 320, let's say 420, and the height, for example, 680. Let's see. If we press right or left, we're still going to have the same results. Okay? Now, even if we change the box width and height, so instead of width to be 30, let's say 60, and height, let's say 100. Okay? And it's still working. So this is good. I'll undo the chains. I like those values. Alright friends, so this is going to be the end of the first video. If you like this one, I bet you're going to like the next one. Because in the next video, I'm going to build on the top of this simulation, but instead of having the box bounces off the ground, we'll add a bunch of springs on the canvas. And every time the box hits one of those springs, it will bounce off that spring. Also, if you guys have questions or feedback, feel free to leave in the comment section so I can either answer your questions or maybe addressing your feedback in the next video for improvement. Thank you guys for watching. This is Fahad from Game Code Bytes.